Alright, so we are on target 1C day 1, and we are writing and solving inequalities. So just some quick vocabulary. An inequality, that's an open sentence that contains one of the following symbols. So that's, the greater than, or equal to, less than, or equal to, depending which side your variable's on. And then we have solution of an inequality. That's a number when substituted for the variable in an inequality results in a true statement. So with an inequality, you likely have more than one solution. Alright, so your objectives for this lesson. I can solve an inequality containing one variable on one side of the inequality. I can determine the solution of an inequality with one variable on both sides of the inequality. And I can write an inequality given a real-world scenario and solve the inequality. Alright, so as far as how to solve them goes, it's pretty much exactly the same as we did back in 1B. So it's the same as an equation. There are two differences. One, with an equation there is one solution, while with an inequality there are multiple values that can be the solution. Two, as far as solving an inequality, everything that you do is the exact same thing with the one little thing that when you multiply or divide, so that's only when you multiply or divide. So that's important. Not add or subtract, just multiply or divide a variable by a negative coefficient. The inequality symbol will change directions. Alright, so let's get into the first example. So we have solve the following inequality for x. So we have negative 2x plus 11 is less than 43. Alright, the first thing you're going to do, just like you would with an equation, subtract 11 from both sides. That's going to clear it from this side and give you negative 2x is less than 32. Now we have a coefficient in front of the variable, so we have to divide by negative 2, and since we're dividing by a negative, the sign is going to flip. Divide by negative 2, that clears out the coefficient on this side because this x always has to be positive, which is going to, and as you can see, I flipped the sign. Here it's opening to the right, here it's opening to the left. So x is greater than negative 16. Simple, right? Alright, second example. Let's make it a little bit harder. We have 6x plus 3 is less than 4x plus 7. Alright. Again, we want to get the variable, all the variables on one side. So take the smaller one and get it to the other side by performing the inverse operation. It's a positive 4x, so I subtract 4x from both sides, which is going to give me 2x plus 3 is less than 7. Then I'm going to subtract 3 from both sides, which is going to give me 2x is less than 4, and then I just have to divide by 2. Now this time the sign's not going to flip because I'm dividing by a positive coefficient. So I get x is less than 2 for my answer. Alright, so now we're going to kind of take everything we've done over the past few days and apply it to a real world situation. So we have this problem. Admission to the fair costs $9.50. Each ride costs you 50 cents. So you have $17 to spend at the fair on rides and admission. So we have to express the number of 50-cent tickets that we can buy as an inequality. Alright, so it's not saying, what's the most you can buy. Remember, this is an inequality. So there's any number we can buy, but it can't be more than a certain amount because we only have $17 to spend. So first things first, we have to set up the inequality. So we've got the admission to the fair. That costs $9.50. And because that admission isn't affected by anything, it doesn't change. We pay that once. That's going to be your constant. And then we add to that the cost of each ride. So we have 50 cents, and then we have R. And what R represents is, so that's the number of rides. So that's our variable. We can buy as many tickets as we can, we can buy as many tickets as we need to go on as many rides as we can with the money that we have left. So this number could be 0. Maybe I'm not going to go on any rides. Or it could be as large as I can make it, while making sure that that number is less than or equal to 17. Because remember, you always want this opening towards the 17 here, because we can't spend more than that. This is the most that we can have. So this amount has to be less than. All right, so whatever is opening towards is the biggest number, biggest value, however you want to look at it. So the first step is to set up your inequality, which we have done now. And then it's just a simple matter of going through and solving it. So we have our inequality. I get this, because remember, I want to isolate that variable. I want to get it by itself. Yep, put that in the wrong spot. So I'm subtracting that 950 from both sides to get this by itself. That's going to clear that side. 17 minus 950 gives me 750. So I have 0.50 R is less than or equal to 750. So that's after I take away that admission fee. And then I just have to divide both sides by the 0.50, which is going to give me 15. Now, remember why I said you don't have to go on any rides. We just want an expression or an inequality to express the number of rides or number of tickets that we can go on. So we can't go on negative. So we're going to say we can either go on 0, so our number of rides can be greater than or equal to 0, but also less than or equal to 15. So your only thing you're really adding on is this part here. This part you just solved and you've done before. You're just adding on this over here, and it just makes sense to do it. So when you see these types of problems in the future, just say, okay, I can't go on more than 15, so my smallest number's got to be to the left, so that's going to be 0. Can't be negative, okay? And you don't, like I said, it's not going to be 1 because you don't have to go on any rides. All right, and that's it for today. I know first two maybe not so bad. Last one might have been a little bit more difficult, but we'll ease you into it. Just take your time, and again, if you have any questions, let me know.